Hey, it's Mr. K, Chemistry 30, Unit B review. This question here, we're talking about some titration stoichiometry or redox stoich. Okay, now this is the hardest question, I think, in terms of steps and possible mistakes and all those things. Here it comes. It touches on a lot of different topics. For any stoichiometry, we need a balanced chemical equation. Then we need to convert into moles, use our mole ratio, and convert out of moles. My work is a bit messy. Please follow with me as we go. Step 1. I want a balanced chemical equation. Here's how I get it. I see manganese here and here. I use that to form its half reaction. I see sulfur here and here, SO2, SO4, 2 negative. And then I go about balancing these half reactions. Okay, next piece. In those half reactions, we've talked about before, but here it comes again. I go non-oxygen hydrogen, sulfur 1, 1, done. 2 oxygens, I need 2 waters. 4 hydrogens, 4 H+. To balance the charge, I need 2 electrons. For the next, 1 Mn, 1 Mn, 4 O's, 4 waters. That gives me 8 hydrogens, 8 H+. To balance the charge, I need 5 electrons. Overall, one reaction has 2, one reaction has 5 electrons. I need that to be a uniform number. That's 5 times 2. That gives me 10 as my number of moles of electrons transferred. Now I combine those and I have my net equation. What I did was I simply stated it back here. 5, 2, 2, 5, 2, 4. Once everything canceled out down here. Now the most important thing is this ratio between permanganate and SO2. All right, let's get down to the information they've actually given us. A 150 milliliter sample of SO2 required 31.5 of 0.01 mole per liter KMnO4. Now, all of this information is about the KMnO4. They give us the concentration and the volume. Concentration times volume gives us moles. So now I know the moles of MnO4 negative. That was my 2. I times it over by 5 over 2, what I'm going to divide by what I'm coming from. I get the moles of SO2. Last thing is, it's asking me for the concentration of SO2. I go moles per liter. So they told me the volume of SO2. So I take those moles, divide it by the volume in liters, and I get moles per liter. They want it in millimoles per liter. So I change this by a factor of 1 to 3 places, or 1,000 places, to convert it into millimoles per liter. Most challenging part, I think, setting up this equation correctly, then doing your conversions, staying organized, and converting to millimoles. So it's all a challenging part, but please be mindful when you're doing your balanced chemical equation. Okay, thanks a lot for tuning in.